Hello everyone, I am going to present about algebra and the outcomes of this video is to learn the significance of determining the number of positive and negative real roots of real polynomials. So here we are discussing about the real polynomials, the type of real polynomials and their roots, and learn some modular arithmetic and basic property of congruency. Understand the algebraic structure, namely group, classify subgroups or classic groups. And first thing is we have to understand the concept of positive, negative, real roots of real polynomial. In the context of real polynomial, the term positive real roots and negative real roots refer to the value of variable, usually denoted by x, for which the polynomial equation equals zero. A real polynomial is an algebraic expression made up of constant and coefficient and variable terms, with a variable raised to the non-negative integer powers, and real polynomial can one or more real roots, which are the values of the variable that makes the polynomial equal to zero. The real value can be classified into three main categories: positive, negative, and zero. Because if it exists, it must be either of the sign, like it is positive or negative, or it is zero. The positive roots, the positive roots of the polynomial of the value variable x that when substitute into the polynomial equation result in a value of zero. And mean by the root is that we have a equation or equation which represent the polynomial equation. When we put the root in that equation, we get it is equal to 0. Simply px is the polynomial. Then if a is root, then pa is equal to 0. Is equal to 0. The term positive refer to the fact that the value a is greater than 0. Similarly, negative real roots, if b is a root which is a root of px, then pb is equal to 0, and negative indicate that b is less than 0. And similarly, we say that the zero root means p0 is equal to 0. Then, for example, px is equal to x cube plus 2x square minus x. Because in this problem, we can take x common from all the terms. This implies that x is equal to 0 satisfy this equation. So, this is the basic concept behind the roots and their sign. Next is concept of positive real root is some non-constant fundamental theorem of algebra. These are the important theorems which prove that there is existence of the roots. Okay. Now, uh, the number of positive, negative real roots of a polynomial can have it determined by the polynomial degree and its coefficient. If you have a polynomial of degree n, then it says that there exists exactly n roots. And now we are discussing about these all n roots are real or not. That depend on the polynomial. The degree of the polynomial is the highest power of the variable present in the polynomial expression. That is, if you have a polynomial like x to the power n plus uh, x to the power n minus 1, then n is the degree of the polynomial. Uh, then the degree of polynomial is the highest power of the variable present in the polynomial expression. It is important to note that the fundamental theorem of algebra stated that every non-constant polynomial equation with complex coefficient has at least one complex root. This means that if polynomial has real coefficient, its complex root must come in conjugate pair, which means that they cannot be purely real. However, the real root, both positive and negative of real polynomial, can still be present. To determine the nature of the root of a real polynomial, we use techniques such as the rational root theorem, Cartwright rules of sign, and the factor theorem can be employed to find the potential real root and their sign. So now next thing is the concept of some modular arithmetic and basic property of congruency. Modular arithmetic is very important concept and mostly used in concept of algebra. Uh, so let's start with the arithmetic and move on to the basic property of congruency. Arithmetic. Arithmetic is the fundamental branch of mathematics. Uh, Arithmetic is the fundamental branch of mathematics that deal with the study of numbers and their property and operations like addition, subtraction, multiplication, division. It forms the basic for more advanced mathematical concepts. Here are the some key concepts of operating in arithmetic. Numbers can be classified into various types, including natural number, integers, rational numbers, real numbers, and if we go further, we get a complex number. So, when the now we come to the main, what is modular concept, and then the concept of some modular arithmetic and basic property of congruency. The operation, addition, combine two or more number to get the sum. Subtraction, find the difference between two numbers. Multiplication, repeated addition, find the product of two numbers. If you want to multiply 3 into 2, this means that 3 plus 3 or 2 plus 2 plus 2 3 times. Okay. Similarly, division, find how many times one number is contained in another. Then property of operation. Commutative property means AB is equal to BA, where we can use a different kind of binary operation. Here we using plus. We can use dot or any kind of direct product, or there are too many binary operation used in uh, any kind of mathematical property. Now, next thing is next point is associativity property. The grouping of operands does not affect the result. Just like ABC, first we apply the operation over AB, then we add C. On the other side, if it is equal to A plus B plus C, means on the left right hand side, first we use the operation over B plus C, then we add A. Now there is a distributive property which use the addition and multiplication both. A multiplied with B plus C is equal to A dot B plus A plus C. Next is congruency, a fundamental concept in number theory that deals with the notion of equivalence between numbers with respect to the modulus. And give two integers a and b and positive integer m modulus. We say that a is congruent to b modulus m if their difference is divisible by m. This is denoted as a equivalent to b modulo m. Means that when we divide a with m, we get remainder b. Or in other words, we can say it a minus b is divisible by m. This is the most useful concept used in computer science and many places. This is very good concept, or very useful in many applications. Now, here are some basic property of congruencies. Congruency first is reflexibility, means that a equivalent to a, because a minus a is always divisible by any number. Symmetricity, a equivalent to b modulo m implies b equivalent to a modulo m. We can easily see that this a minus b is divisible by m, so obviously b minus a divisible by m. Transitivity, if a equivalent to b mod m and b equivalent to c mod m, this implies that a equivalent to c mod m, because a minus b divisible by m, b minus c divisible by m. When we add two numbers which are divisible by that numbers, then the addition is also divisible by m. So then by cancelling b to b, we get a minus c divisible by m, which give us a equivalent to c modulo m. Additional property, there we can add two modulo system. Multiplication property, we can multiply two modulo system. Cancellation property, we can divide two modulo system. Okay, thank you.